The sharp observer will have seen on the NLNOG website that for weeks there was this secret topic. And we didn't want to disclose what could be said. You don't want to run into libel. But now we have enough confidence that this can be shared with the public. Thank you.
Thanks. So we just heard from Reo, the internet has some trust issues. Unfortunately, it has some more, and we'll be discussing those now. So, first, very briefly about us. We are Thijs Alkemade and Christiaan Ottow from Computest. Thijs is one of our security specialists, so in his daily work he breaks stuff in a very responsible way. And I'm Christiaan Ottow, I'm a security coach at Computest. So in my daily work I support our guild of security testers and I work on the longer term security propositions we have. So very briefly about us, we're a tech company that's good at verification of software and infrastructures. So basically in terms of performance, security and functional testing, we help our customers have a dependable software and infrastructure suite. If you'd like to know more about that, you can catch us later. We'll focus on the technical stuff now. So a few months ago, something very interesting happened. Thijs discovered a vulnerability in Start Encrypt, a product of Startcom. And we published about this, and now it has had some fallout, some new discussions have started, which we think are very interesting to discuss, and which we think deserve attention of the broader tech community. So first we'll go into the technical issues that Thijs discovered, and then we'll talk a bit about the fallout and the follow-up.
Okay, so first of all, I'm going to talk a bit about TLS. So I assume you all know how certificates are used to secure your traffic. We all heard to talk about DANE and how that's used for SMTP, for example. Many of you will probably have once requested a certificate, but if you don't, there's basically three flavors. You can get it domain validated, an organization validated, or an extended validated. Domain just means the CA checked you control the domain. Organization, they checked the domain and they checked some business records of yours. Extended means they extensively tested your business records that you really are a company located where you say you are. So for example, this is one of the certificates we have. It lists where we are and it's clearly visible in the browser where you're connected to. So it helps if you're connected to a bank. But aside from that, there really is no technical difference between all three levels of certificates. There are very little things you could not do with the domain control validated certificate that you couldn't do otherwise. Well, that you could do with extended but not with domain controlled. So they are just as risky as others. So how does domain control validation work? Well, there's a specification for this. And that's being discussed by the CA browser forum. That's, the CAs in the browsers, they make guidelines for how you can issue certificates, what must be on the certificate, what must not be on the certificate, and how they must check that you really control that domain. There's a couple of ways they can do that. These are just a few of them, but the most important ones. So they can check whois data and get an email and then send a token to that. Or they can send a token to one of these administrative addresses on your domain. Or they can tell you, well, please edit this website, and then they will check that you added a token or something, and then they give you a certificate. Or, the very last one, any other method which is just as secure in the CA's opinion. So you can see how this is a bit of a bad guideline, because now they can do anything and they say, well, we think this is just as secure, so here, have a certificate. So what I'm going to talk about now is how much control do you really need to have on a website to be able to get a certificate for that website. There are many different websites, you all have different functionality, but there must be some websites out there where you can get a certificate even if you don't own that domain. So this is how Komodo does the web validation. They ask you to upload a text file. So a CSR is a certificate signing request, which is basically just something signed with your private key to ensure that they really know which which public key is yours. So they ask you to hash it, upload it, and then put these contents in it. Well, this doesn't really seem that secure to me, because there are many sites where you could upload such a file. For example, there are many CDNs or other places where you can upload arbitrary files. So for example, on github.io, which is GitHub pages where you can upload your own files, you can probably use this method there. There are other things like bit.ly where you can make redirections. Well, in the Komodo case, this wouldn't work because they explicitly say that you cannot have redirects, but maybe other CAs will allow this, or CDNs like Amazon. So now I'm going to look at how Let's Encrypt has implemented this. So Let's Encrypt, you probably know that it's a new free CA, which has an API which you can easily use to obtain certificates. And they have carefully documented how their certificate retrieval works in hopes that other CAs will implement the same thing, so we don't end up with the same mess that we currently have. So this is how that flow works. So you tell the Let's Encrypt, I want a certificate for example.com. They tell you, put this token somewhere. For them, it's a path under /.wellknown/acme challenges. So you can't just upload it anywhere. Then you upload that, you tell it to go retrieve it, they retrieve it. And if it's correct, then you get a certificate. It's pretty easy, it's pretty simple, it's great to use. And after that, it got really popular. There's about 5 million Let's Encrypt certificates issued about now. And that must have hurt the business of Startcom, which was another company, a CA, which was issuing free certificates. So they probably thought, well, we're losing a lot of business, let's make something similar. So they started the Start Encrypt project, which is also something you run on your web server, and then it reads a configuration and it talks to an API for Startcom, and then it does the authentication and then it gets certificates, automatically installs it, and it should be great, except that it didn't really work, and that it was horribly vulnerable. So this is how they did it, and it's slightly different, because now you still request a cert for example.com, but instead of saying, well, put this token on this path, they just say, well, put this token somewhere. And then you put the token somewhere, and then you tell the server, well, I've put that token on this path on that server. So if the server has the functionality to upload avatars, and they don't check if it's really a valid image, if you can upload attachments, or if you can... There are all sorts of things where you could abuse this to get a real valid certificate from Startcom. So some examples for sites where you could do this is GitHub. You can easily upload files there, that's the entire point of the site. Dropbox, you can create public links to files. There's even functionality on google.com that you can use for this, namely because they have an open redirect. Now Google themselves don't consider this a vulnerability, but in this case we can abuse it to obtain a certificate for them. That basically means that they have a redirect, they have a page where you can supply a parameter and then they will redirect you back to that page. So then this happens. So instead of giving instead of uploading it to the site that you want to target, you upload it to your own site, and then you link to the open redirect. The open redirect will then automatically redirect the Startcom API to your own site, where the token is. They will follow the redirect, so instead of the Komodo example I gave, they do follow redirect. And then they give you a certificate because you've validated example.com and not attacker.com here. So this is a very serious problem because the number of sites where you can exploit this is enormous. There's a specification for OAuth which practically mandates that you must have open redirect somewhere in order to redirect users in case some error happens. So we had a really long list of sites that were probably vulnerable to this. And yeah, that just completely breaks every trust that you can have in a certificate, because the CA could just roll this out without any auditing at all, probably, because there was just so many mistakes made in making this. Now, and after that, after we published, I went back through the certificates which I found, and then I realized I had gotten one particular very interesting certificate out of it as well. So there was a parameter somewhere which said CA ID 2. Now when I see an ID of 2, I'm going to try 0, I'm going to try 1, probably everything up to 20. And one of them gave me a certificate with a date in the past, which was very interesting. But I didn't realize it back then, because it didn't seem valid to me then, because I had never heard of Wosign, probably some Chinese company, and it didn't look, I couldn't get it to validate then, so I just ignored it. But then after we published our findings, I realized, yeah, it is trusted, and there's something else very particular about the certificate, namely it has a SHA-1 signature. Now, SHA-1 is an older hashing algorithm which is no longer allowed to be used for signing certificates by CA since January this year. So what they were doing here is, instead of upgrading to SHA-256, which may not be possible for older hardware, they had an API for which you can request a certificate which was backdated half a year so that it would still be valid in browsers. So Chris is going to talk a bit more about the timeline of events. Thanks.
Yeah, so here's a short timeline of how things progressed. On the 23rd of June, we reported our issue to Startcom first, of course. So we found a contact for them, and they reacted very quickly. They started fixing immediately, and after some back and forth, they had fixed it on the 29th. And they announced to us that everything was fixed. We didn't validate that. We trusted them for their word, and we published our findings on the 30th. Shortly after that, I didn't put it on the slide, I see, but we realized that some of the issues weren't fixed. So the most important issue was fixed, but we had a list of about 6 or 7 issues, and some weren't, so we emailed them back. And then they took the API offline completely. And a few days later, they even retracted the whole product. If you go to their website now, it says coming soon for Start Encrypt. In the meantime, Google Chrome security team approached us asking for details and asking if they could have the certificates. Because what we didn't realize at first was that the backdating thing is much more interesting in this whole discussion than the getting free certificates for different domains thing. I mean, fixing a software vulnerability is one thing, but a CA that is doing backdating on its certificates catches more attention. So Google got to work on this issue, and they had some communication with Wosign via their own channels and with Mozilla. But apparently the discussion didn't really go as planned, because on the 24th of August, a few weeks ago, Mozilla sent an email to their policy development mailing list saying, okay, these are all the violations of Wosign community, what should we do? That's a very bold question to ask. If you're a CA and your business depends on being able to issue certificates, on being trusted by the browsers, and then suddenly one of those browsers says, okay, community, what should we do about this? We don't know. Then that mailing list discussion becomes the answer to your business. So that's a very strange discussion happening there, and a lot of emails being sent over that mailing list. And the question is, who should intervene if a CA misbehaves? So who is in control of this? I mean, the browser has a list of CAs that it trusts, and there isn't a single one over those CAs. They are all equal in terms of trust to us. And there isn't one browser, I mean there are many, and then there are the trust stores that come with your runtime environment for Java, and the trust stores that sit in your embedded devices. So there is no single authority on what browsers should, or what CAs should do or not, and how to intervene when they violate things we think shouldn't be violated. Okay, so I'm overstating it a little bit. There is the CA Browser Forum, which is a discussion group of CAs and browsers together, and they have published the baseline requirements, the BR. And those baseline requirements state a list of things that CAs should adhere to. For instance, thou shalt not issue SHA-1 certificates after January 1st of 2016. But what happens when a CA does? What can the CA Browser Forum do? Is such a transgression enough to pull them from the root? So the discussion erupted, and very quickly Wosign realized how serious this was for them. and they started responding to the issues. And to most issues, they said, sorry, we're really sorry, we have really learned the lesson, and we won't do it again. Which didn't get them very far. To other issues, they said, well, the English in the BR is too difficult. We didn't understand the requirements. Another issue that was raised, on the URL there, you can look at a later time, there's a list of issues starting at issue D and ending at issue Q, I think, of violations, possible violations of the BR that WOSI needs to answer for. And one of them is that Startcom is apparently wholly owned by a company Startcom in the UK. So Startcom Israel is owned by Startcom UK, which is owned by Startcom Hong Kong, which is 100% owned by WOSI, which is 100% owned by a single man, who is also active on the mailing list. Actually, Mozilla did some research into this and published it to the mailing list about half an hour ago. So it'll be interesting to see how they react to that, because they've been posing legal threats to people who publish details about how they operate their business. So WOSI did a few things. They said, sorry. They said, you're not allowed to publish on how we do business. And they said, we will publish every certificate we issue to certificate transparency. So begin 2015, every WOSI certificate should be in certificate transparency logs now. Well, that's a good step. Certificate transparency is a system where you can submit certificates and they become auditable in a sort of a public ledger system where you can only add information and you cannot modify or delete. So we have this public service where you can search for certificates, and that's the only way actually we get some insight into what a CA is doing. Because how will we know if a certificate for Google.com is issued by Komodo tomorrow? We'll never know until we encounter it on some network connection. Until that time, we don't know what certificates are out there for Google.com. Well, using certificate transparency makes it possible to search for what certificates are actually issued for what domains. So that's a good step. And they committed to including SCT data on every certificate after July 5. So when you publish a certificate to certificate transparency, you can also include the proof of this on your certificate. That's a good step as well, because then we know that every certificate we encounter with SCT is traceable. But it doesn't really answer to the trust issues we have with WOSI. I mean, if they publish software in the way they did, if their ownership just migrates around in the way it has, if they have misissuances as they had, if they use the same certificate serial number for over 300 certificates, and they say, sorry, it's a software bug, it might be fixed with the next release. And then the question becomes, if a CA behaves like this, what then? What are the scenarios? What can we do? Well, there are a few things we can do. We as a community, that is, led at the moment by Google and Mozilla, who are actively participating in this discussion. And usually the other browsers follow suit, because Mozilla is the one with the most public discussion, while if you want to have your CA included with Apple, you need to send some emails to an obscure address and then hope for an answer in some time, and perhaps you'll be included. With Mozilla, it's a very public process where people can comment. If you look at the mailing list now, you'll see the inclusion request for Amazon, which is being discussed by everyone, and perhaps they'll be included as well. So what could be done is Mozilla and Google could decide to remove the CA from the trust stores. So that would mean that everyone with Firefox or Chrome browser would stop trusting WOSI signed certificates. That is quite effective. On the other hand, people might just add the CA again, or in their enterprise rollout, computers with the CA provisioned in it. And of course, it requires an update to all the browsers. Another option would be to actively distrust the CA. So to provision the browsers with a rule that says if it's WOSI, distrust it. So then even adding the certificate to the store again would not work. That's very rigorous, and it leaves the people victimized who now have certificates of WOSI. They didn't do anything wrong, they bought a certificate, and suddenly their certificate isn't trusted anymore. So a solution to that would be to remove the CA from the trust stores, but include a whitelist of certificates that have been issued until now, so that those people don't become victims. This is interesting, and on the mailing list there's some discussion about the size of this whitelist and whether it would be viable for mobile devices and for embedded devices, because we're talking about a few 100,000 certificates here. We could distrust certificates with no CT information, and we could do the same, but then with the whitelist. So distrusting them without CT information would help up to a point. We would at least know that every certificate from WOSI is auditable on a technical level. But it, of course, wouldn't solve the questions we have around how can a CA operate and give out duplicate serial numbers, for instance. So these are a few of the possible scenarios that we see right now moving forward. We don't know which one it's going to be, of course, so this is all speculation. But it does go to show the complexity of a decision that the CAB Forum has to make. So if WoSign would be removed from the trust stores, they could still continue issuing certificates because their CA has been signed by multiple other CAs in the period leading to their inclusion, because the inclusion process took so long that some other CAs signed their CA certificate. So effectively, they would become an intermediate and still continue issuing certificates. If we distrust WoSign, they could continue to issue certificates under Startcom. If we distrust WoSign and Startcom, they could continue to issue certificates because of the cross-signing under other CAs. What they have proposed themselves is the top right suggestion. They propose that they will be distrusted for certificates which have a country code other than China. Well, this sounds somewhat reasonable. On the other hand, it doesn't solve anything. Because will you notice, if you go to google.com and the certificate has country code CN instead of US? Another suggestion is to distrust them for common names that do not end in .cn. Well, that's a bit problematic. Many Chinese companies have .com host names, and this would require some special patching to all browsers as well. Another scenario is that WoSign overnight improves operations so dramatically that we are able to trust them again. Well, that would be nice, but it's difficult to prove. And then the last one, WoSign and Startcom are distrusted, actively distrusted in all browsers. Then they would probably go bankrupt, and the internet might be a little bit safer. Because they could not operate under the cross-signing, because they're actively distrusted instead of just removed from the stores. Okay, so just a few words on what you can do yourself to minimize the risk of misissuances on your own domains. Because, I mean, in the end, we have to trust the CAs, but there are a few things you can do to prevent exploitation of the issues as Thijs described them. So the first is blacklist the .well-known/PKI validation path. This is part of the ACME protocol that Let's Encrypt has developed for this type of certificate issuance, and it'll be adopted by more CAs probably. For instance, Start Encrypt has said they will adopt ACME as well. You should reserve a few email addresses for admins because they're used for certificate validation. Most of you are probably already doing this, but especially if you run a webmail service and you allow people to create their own email aliases, you should be very careful of what addresses you reserve and what addresses you put into your whois, because those should be added to this list. And there's even some CAs who have special email addresses that are not part of the BR and they're not in your whois, but they still work, like SSL admin. And of course, as always, you should be very careful of DNS records, because those are used for validation. If you allow people to somehow get custom content into TXT records, which are more scenarios for right now than there were a year ago, then you might have a problem with this as well. Okay, that's all we had on this topic. I'm very interested to hear thoughts, questions, maybe even solutions to the trust issue we have with certificates.
Thank you so much. It makes me incredibly proud that our fellow Dutchmen continue the rich heritage of SSL issues that the Netherlands has known through, for instance, DigiNotar. Oh, this is fantastic work. Thank you for sharing this. Any questions for these two gentlemen?
Hi, Andrei Tsaletka, Cesnet. I think it's even worse, because in the case of actively distrusting, for instance, if I would now like to actively distrust WoSign CA, many platforms just don't allow it, and I'm talking about Firefox. There is a GUI for it where you can distrust it, but it has no effect on intermediate certificates. It's a bug that is open like 6 years ago in Firefox and nobody's taking care about it.
I welcome you to contribute that to the mailing list, because I'm sure they're very interested in that right now.
Hi, Sander Stefan. You forgot to mention one really interesting thing about WoSign, is that if you can prove ownership of a subdomain, they assume you have the ownership of the whole domain. So if you can get a subdomain validated, you get everything.
Yeah, they're very easy to work with, let's say. Hi, Erik Pijs, speaking for myself. The question that I have about the actual one person behind this all, how likely is this that it's a man in the middle, basically somebody setting this up the way it is on purpose? How likely? What purpose would you imagine for that? There are several things you can think of. Using the certificates to decrypt stuff in China Great Wall, things like that. Well, I think there are already a few Chinese directly government-owned CAs in your trust store. So if that were the purpose, perhaps they'd have more methods to do this. And I would think if that were their purpose, they'd go about it slightly more professional, so that it doesn't stick out like it does now. But I don't know. Occam's razor says that the simplest solution is probably the right one, and this looks like a very clumsy business. Okay. It might be more.
All right, thank you.